G'day guys, going to go for a deep dive on the GPX-6000. I have had people ask me, and I have had emails and all sorts about the dongle, how to get around it. And I've had people say, oh, look, you can talk to this guy. He'll know how to get around it. And I did talk to the guy specified, I was told to talk to, and he asked me what was in the device, and I said, oh, it's got a DS28E38 chip in it, and it was just dead silence on the other end of the phone. In other words, I don't think you can get around it. If you want to have a look at what this thing is in the dongle, in the coil, that's what the chip is, a DS28E38. And as you can read there, deep cover secure ECDSA authenticator with chip DNA puff protection. I haven't even bothered finding out what puff protection is. Does that mean that it has protection about letting smoke out of it or something if it goes puff? Oh dear. So this is a very, very smart, well, I won't say no, it's not smart. It's encrypted, and it has heaps of countermeasures that you will not be able to get around it. Okay, so there's a couple of chips in this detector. I'll go through all of them, so we'll have a look, and I'll give you a bit of a rundown on what these things do and how it all works. But if you want to read the whole lot of it, right, it's cryptographic, which means it's encrypted. And if you want to read about this thing here, here we go. 17-bit one-time settable, non-volatile decrement only counter with authenticated read. Basically, this is saying that you're not going to decrypt it. You're not going to magically whiz up a chain of data and have it unlock and make the detector work. If you haven't got it, it ain't going to work. Okay, so we have a look here. God, it's also got a 64-bit ID, ROM ID inside it, unalterable, and there's a lot of interesting things about this. It's a tiny little package, as you know, and yeah, you can buy them. Yeah, you don't. I don't think you program these yourself. You buy them pre-done, and applications. And this is where you can see the applications here. Medical sensors and tools, so you don't get the wrong thing in the wrong hands, like hit someone's eyeball with a 10-watt laser instead of a 100 milliwatt laser or something. I don't know. Yeah, secure management of limited use consumables. So this is telling me those chips are dirt cheap. They're just not worth much at all. You buy them in massive amounts. So they put them in printer cartridges. You know, people were refilling printer cartridges, and then all of a sudden, oh no, if it got down low and it tripped a little sensor, and you put in new, ink toner, whatever, it would say, sorry, you're not going to work. So that's why people got very, very fussy about what printer or anything of that nature they're going to buy, because if they have these chip things in there, they could give you that printer for nothing, and then you are absolutely screwed, forced to buy the manufacturer's replacement products, most likely at a greatly inflated profitable price. So they just want to get you in the door. That's why a lot of these printers, a while ago, you could buy them for $20. Australia Post had them for, something like that, $25 or something. But yeah, the consumables, that's where they get you. So I've got my old laser printer down there, which is not chipped or anything, and I just keep putting more toner in it, and I've had it for years. So don't get caught with that sort of stuff. So basically, there's a bit of a pictorial how it works. And this chip too, you can't even wafer probe it or anything like that. It has layers in the chip design that if you try and grind it down to probe it and measure things to see if you can get the code out of it, it won't work anymore. It'll just die. That's the end of that. So it's basically anti-everything. You can't get at it. And we could probably say this was just put in there, in my opinion, to stop anyone making coils for these things until you hack this out of it and then stick it on anything you want, because it does work. But there's another part to this too. Inside the detector, this chip does not just communicate directly with the CPU or MPU. There's another thing here, which is the DS2413, and it is a one wire, basically it's a one wire and a return addressable switch. Okay, so that other device, the one here, that DS28E38, communicates with this one. And yeah, if you have a look at it, basically what it is a, I should have read up more, I could tell you what it is, but I'll just have a look at it now. I think it's a waveform shaper. If there's too much delay from the chip in the coil to the CPU or something, something goes haywire. And this thing here cleans it up. Yeah. If you read up on it, it'll tell you anyway. But there's a lot of data there. I think where's a write-up on the thing? Here's the overview. Okay. Yeah, it's to do with comms at particular speed rates or baud rates, or what you want to call it. So basically, it goes in the middle. So my way of looking at things, this is just an opinion piece. If you're looking at this, you got to take note that authenticator chip in the coil then communicates with this. I'm just trying to find. Where is it? I'm trying to find a schematic. 241. This is a little bit complicated. It's a little bit above my pay grade. I'd have to read up and get definitions on it all. But I'm pretty sure it's a you can connect a lot of different things to it, a lot of authenticator chips to it. There's a function flow chart. I don't want to get into that. It'll bore the hell out of anybody. But what we want to do with this, we've got, God, they've gone absolutely completely crazy on the protection of you must use our coil to use our detector. So this is unreal. It really is. If you want to read up on these things, I've put enough info there. You can find them, have a read. And yeah, that basically goes into the, not that one, but this one here, that goes into the micro. So, you know, I'm just thinking with the way I used to do boards years ago and some other devices I know, that if you had to have something connected to it to make it work, in a lot of cases there would be 2 points you just connect together or something, and it would bypass it. And it wouldn't surprise me if it is in that detector somewhere, but no one knows where it is. I don't know. There is hundreds of little test points on all sides of the board. So, you know, rather than trying to work out the ins and outs with these coil function chips, the whole thing like that, I think you'd be better off trying to rewrite the code for the CPU. It would be easier and ignore those things. All you'd have to do is have a look at the pin functions on the CPU. Very hard to do, but have a look at the operational aspects of what that CPU does, what it controls, and back engineer it if you could. I don't know if you could. Be a hell of a job, but never say never on that. That sort of stuff. When it's controlling timings and that, you can see damn well what's going on. You may be able to utilize a lot of stuff that's there. But then again, we don't know what's in that black module inside the device either. The receive module, which the magic blue earth wire goes to. And if you do anything, which I've been told, if you do anything with the blue wire and short it to ground of the coil or active of the coil, it'll blow the detector up. This is an absolute time bomb of a thing to try and do things with the coil. If you do something wrong, if you think it is a standard coil like on a 5000 or GP or something, it will probably blow the detector up. You have to be dead careful what you do. So the thing is also as well in the coil, I should do a show and tell on this thing. That's the coil wire out of the detector coil, the coil end. It's part of it. It's not all of it. The dongle's in there as well, but this isn't the dongle. As you can see, you have a black wire and a red wire there. Those wires there are for that authenticator protocol chip, which is that one there. They go to that chip. They are also made of Litz wire, I found out. So if there's anything, they don't sit there and regenerate any currents or anything if they're getting energized somehow. Who knows? But they are Litz constructed. The blue wire there, everyone would think, oh, the blue wire, that blue wire, you'll just connect that to coil shield. No, you don't. If you do that, you'll blow your detector up. Do not do that. The blue wire there has to go on a floating shield assembly on the coil. It cannot connect to ground. It can't have any leakage anywhere. It will go bang. First of all, we'll have a look at this little board here, and I'll tell you what's what. There's a big inductor here. Now, I've measured that inductor. To me, it's 0.35 microhenries. And next to that, there is a power resistor, that black thing there on my finger side. It's probably all out of focus. I can probably zoom in on this, but then everything else will go haywire. I don't know. Go on, focus. There we go. That the thing on the left-hand side is the inductor. The thing on the right-hand side is an 80 ohm power thin film resistor. It's probably a some sort of film type, non-inductive. It's got an inductor next to it, but it's part of the circuit. And above that, I think it might be a 100 or 120 picofarad capacitor sitting there. And that inductor, the coil connection on that one there is in series, goes to the coil. And on the ground side of it, let's remember, I have to look at this again. The ground side of it goes, I have to make sure, goes through that resistor. This is interesting. The coil has to connect to that, doesn't it? Now, I'll need to get my multimeter for a second. I'll zoom that back out so you can have a look at that. But I need my multimeter because even though I measured the parts individually, I thought it was connected a particular way, but it might be connected a different way. I need to find out. So I'll just get this meter here. Come here, you. Okay. I just want to make sure the ground isn't just, or should I say, the return of the coil, not ground. Hang on. There's a bit of wires all over the place. Now I'm going to hold it with my knees to make sure something here, because that something just looked a bit weird. Okay. No, it's not. The ground, try again. The ground here does connect to the ground connection here. But what we got here with this inductor, we have, from memory, so I'll double check because I don't want to say it the wrong way around because someone will blow their thing up. Okay. So that connects to that, that connects to that. Okay. Let's make sure that doesn't go onto that. I'm pretty sure. This cable's so thick it's very hard to control. Perfect. Okay. Now I know what's going on. A lot of these times I look at this stuff, it's not very interesting, and I just, oh yeah. Okay. The ground goes through here. The resistor goes on to, oops, I'm trying to look at what I'm doing and not looking in the back of the phone. So I do it by looking in the back of the phone, so I'll drop my hand down. That there connects to here. Okay. That then goes through that capacitor and back here. This goes to the center conductor of the coil, and this bit here is, so it's sort of a little RC type filter. And this inductor, very, very small value, is in series with the coil, or the active, the inner. So yeah, 80 ohms, 100 picofarads, and that. So it's some sort of filter or something of that nature, and it works without it. So I made coils work perfect without this. So it may be some sort of compliance thing. I don't know. I really should fire one up and look at it. But I'm going to tell you something, guys, and you'll like this. The biggest problem with trying to work on one of these detectors is the noise. So what I've done, made myself up a cancel coil for it, right? So now I can work on them and be dead quiet without having to go out in the field and come back and then go out in the field and come back. I can run these in the workshop. And yeah, as you can see, I've got that on a piece of, if it ever comes up, here we go, let's follow it. And we'll follow it up and follow it up. And we even have the right connector on there. So then we got a dongled coil. And if you've noticed, I've got the dongle sitting there. See the black and red wires? That's the wires that go to the dongle. And what I've done here, I've got two iron powder ferrite, slap me, iron powder cores. They are not ferrite. And I've got two of those taped together, and I've put that dongle in there. That will shield that dongle from any high power output from the coil if it goes near it or anything like that. That dongle is protected. So, you know, they do that in the coil as well. The manufacturer does that. They puts it in a ferrite one, but that is bulletproof. I could probably drop that into the field of the coil, and the coil won't even know it's there, and it won't even know the coil's there. It just makes anything that can blow it up gone. So now we have a way of having a very low noise input into the detector, and you bet I put a lot of sleeving and tape on this, because remember I said that blue wire, it touches anything, kaboomo. you do not want to blow up your detector. I've done this. I triple protected it. Like, I'll do it once, I'll do it twice, I'll do it 3 times. So, and then I'll get this and I'll put it down on a nylon, fix it to a nylon chopping board. So nothing ever moves and it won't blow up ever. That's the way to do it. But that then allows a lot of experimentation to occur with the 6000. So there'll be a lot of stuff to do in the 6000. I've actually discovered more stuff to do in the 6000. Shouldn't say that because I've already done a lot of detectors for people, making them quiet. But having this, I'm going to put in some really hard yards doing the 6000, and we'll get it going as good as we can. Because I tell you what, it is a damn noisy detector. It does have some very, very early sampling in there, and yeah, and it is running a fair whack of gain. That's why it's probably noisy. But I've actually have come up with a way that we can control the input gain on that detector at the input proper, rather than back in the circuit, and we can manually override a lot of functionality. But it's one detector you've got to be very, very careful with. I wouldn't be a newbie doing it. You'll just blow it up. Don't touch it. In all honesty, don't muck around with the coils, because it is a minefield of danger if you get something wrong. I'm very aware of not to do things that are wrong, so I don't have that issue of having egg on face. Now, I've got to tell you another thing. Had a fellow send a detector in, and he said that it goes out of ground balance all by itself. I'm going, that's weird. How does that happen? And I fired it up. I fired it up here. I tested it, and it ground balanced perfectly. I said, okay. And I came back to it, and about a minute or two later, it was a little bit out, and it ground balanced it. Ground balanced perfectly. Okay. I left it for 5 minutes running. Came back, it was completely out of ground balance, all by itself. Now, I left it in tracking mode because I was ground balancing it. So what I did then is I ground balanced it and put it in fixed. When I came back, it was out of ground balance in fixed. This is really weird. And it's the most weirdest thing I've found. And I should show you this, but that would mean I have to move over to the other bench with this camera. So I might as well do it. I think we've learnt enough not to muck around with the authenticator chips and that in the 6000. Just bust them out of an existing coil and use that for all the coils if you want to do that. Now I'll get over here. Hang on. Going to take a bit of modification with the legs on this. Okay. Here it is here. I've got the other chair jammed on me. Here we go. Spin around. Go away. Get away. Oh, hang on a sec. I have to bring the microphone over. I forgot about the microphone. Yeah. Okay. I'll stick the microphone there. People say it sounds okay if I do this, so it's a good way of doing it. Okay. You're not going to believe this. I didn't believe it either. Oh, and thanks to someone who said, I don't like your fingers in the circuit boards, and they sent me a filed off knitting needle. I know the fellow who sent me this, I guarantee you he's an RF man, because I used to knock off my mum's knitting needles and file screwdriver ends on them to use to tune ferrite inductors years and years and years ago. Anyway, let's get on to this. Okay. This will be really weird, but I hope I'll zoom in a bit. I'll just get this thing on angle. Okay, zoom in a bit more. Okay, this Mylar connector strip. Now, this is the natural way it was. Most of them I have seen, actually, all of them I have seen, watch this, are in, oh, it's not going to do it now, are in that position like that. And I'm suspecting, I'm not sure, I'm suspecting, I've got to prove it out. I think I'm right because I did some experiments and it's come up saying that I was on the right track. I bent it down like that when I was playing around with the wires here and it's just jumped up again. And I found that the ground balance was changing and then being stable when I was looking at these. And I'm going, what's that got to do with anything? So I actually took all the boots off and gave them resoldering on all the connectors there, as you can see. They're all resoldered. But I got a feeling this line here, which goes to the ground balance handle switch. Okay, this is going to sound really bizarre, and you're going to go, oh, that couldn't happen. But I think what I'm going to say does happen because on most of these, they're all down like that. Okay, and that aluminium or aluminum, whichever way you want to say it, alloy, is connected to ground. So they would act as like a ground plane and a low impedance point and basically act as a shield, a place where any stray radiation, I mean, not radiation like, atomic bomb type, but I mean like radiation from the switching currents, from the wires, from the coil, can't really get at it. But when it has popped up like that, it acts as an antenna. This is reality and theory and my opinion all thrown into one. So if that's acting as an antenna, and this here is your button for throwing it into the opposite to whatever you got to switch in. If you want to put it into fixed, hold the button down, or tracking, hold the button down, or whatever you want to do there. Well, it's getting bursts of data along here because it's got conductive tracks in there, and then it goes off into the circuit board. So what's the likelihood of leakage here getting into that? I think it actually does that. I think it gets in. So all you detector operators out there who are having absolute hassles with your detector and ground balance stability, maybe you want to get this and hot melt glue it down like that, which I'm going to do. And I think it'll cure it. It was bizarre that it was doing that. So if I leave it alone, it'll eventually pop up because that's how naturally it was. It was in a pop-up position. But so many of these I see, they're always down. They're not popped up. And I think it's luck of the draw on when this little three connectors here on that little connector, the little three little contacts get soldered. Was it up or was it down? And if it was down, I think it behaves, and if it's up, it doesn't. I might be wrong, but I'm pretty sure I might be right. It's 50-50, but I'm going to have to put it back together and put that down, and I'm going to see if the ground balance drifts off. So it's something to be aware of, and I'm not going to keep that as a secret source under my kit of secrets. That can be public knowledge because how many detectors are out there and you're having ground balance issues, and it could be as simple as that. There you go, down. I really think that is rather amazing. But anyway, I've probably yabbing on about that too much. So, oh dear me. So at the moment, I've been building up different coils uh, for the 6000. Had a good look at what was in the 6000 coil and that. Um, if you want a 6000 coil, I don't know if you can actually get them at the moment from the other manufacturers because like that American fellow told me, who should know what's going on, that, in his opinion, in my opinion, that the others have had the choke hold put on them, as he said, the choke hold. So if that's the case, you might only be able to buy Minelab coils. Or if you want, sacrifice one, hack it open and pull the dongle out and make yourself a different coil. Or, or just make a dongle up. It works perfectly out of the coil or anywhere. It doesn't make any damn difference. And, like I said too, all that inductor, resistor, capacitor, we'll call it an RCL network. It's probably a filter of some description. And maybe it's, look, I'm only guessing, but maybe it's there to stop very fast transients, corrupting the data in the dongle. I don't know. I'm just suggesting things it possibly could be for, or it could be a little bit of an EMI filter. I don't know if it would do much, but I can experiment. I can fire up the signal generator, put it in series with the oscilloscope, and we can see where it starts affecting signals. See if it's a cutoff filter or what it is. Who knows? I don't know. The only person who knows is the person who designed it. But I'm suspecting it is probably something to snubber out very high-speed transients that were causing an issue. Possibly. I don't know. I really don't know. The only way you will know is you go and do it. Do it on, do it off. Because I've got the dongle up near the when I've pulled the dongle out of the coil and put it up near the detector, basically, I should have the connector in front of me, shouldn't I? I should have. Where are you? Oh, there you are. Because I did. God, it zoomed in too far now. Hang on. Oops, wrong way. Fat fingers. Yeah, because I had this one here cut off and done like that, and the dongle was just here. So it was very, very close. The dongle was here and very close to the detector. That maybe not having it in circuit it didn't make any difference. I could not tell. So maybe it is something to do with that authenticator chip protecting it and stopping the data being corrupted or something when it's doing its handshake. Hello everybody, I'm here. Sorry, hit a couple of error bits. Oops, you're not the right coil. Go away. I don't know, but it's just something to be aware of. But yeah, we have interesting things happen here all the time, I tell you. This one here is an absolute doozy of, that ground balance wandering off all by itself. So that would, like if you're in fixed ground balance, that would be driving you bonkers if it started drifting and you think you're in ground balance and you're not. So I think that's important to investigate and just see if that is an issue. It's that sort of more or less. I don't know. I'm not going to say. I'm not going to say because people will take it the wrong way. I was going to say it's sort of a little bit out of the manufacturer's control because it's the last thing that goes on the detector. Put it on, plug it in. Yeah, it works fine. Does a ground balance. Yeah. They're not going to sit there and do each detector for 5 or 10 minutes and see if it drifts. I don't know. Maybe they do. Maybe I don't know. I'm just saying I don't know. I'm just suggesting. But is that an issue? I don't know. But on the end of here, on the end of these, it does have little inductors or capacitors, a little LC, I think series inductor parallel capacitor network near the connectors. Maybe they're not there, but they should be there. I haven't actually looked. Let's have a look. No, just near. If you can, I'll show you where they can live anyway, just so you know. You see those there? That's all the filters for where those mylars connect into these long socket things. Is there any on the other side? Yeah, they're on the other side as well. I think there's inductors and there is capacitors. But anyway, that's what that is. So, yeah. Anyway, I'm going to go and put this back together and see if I've cured the ground balance problem, the drifting ground balance problem with that, because it's just very strange. Very strange indeed. I could actually hear the detector changing tune, very slowly, but it was changing pitch. So I suggest that something in here was getting whacked with signal, with current pulses. It was just coupling in through, neutral coupling, and started doing things into the circuit, starting to read it as digital values, and making things go out of whack. But I will find out, and I will definitely do another video and tell you the absolutes on that. So a lot of things I do in a video, I'll do the experiments and so forth, and then I'll make it known in the next video. So you might have to actually, if you want to know the whole scenario, you might have to go 1 or 2 videos back and look at the next one, or whatever. Yeah, anyway, that's enough waffle. That's good enough. Half an hour. Oh, no, 37 minutes. That's enough. Okay, guys, I'm going to get stuck into this. Next thing you'll see is I'll have a 6000 hooked up on the cancel coil, the figure 8 coil, because I don't want to get involved and try and do a reverse phase double D coil type thing for it. I'll just use a flip mono. It's much easier and more controllable. I don't like having. I think actually that the detector is possibly told what coil it has with the dongle, with the authenticator chip. It may be programmed to output and say, hey, Mr. CPU, this is a double D coil. So you may need one of those. I don't know. MindLab's not going to tell you, as far as I know. That's that much out of the bag, and yeah, you have to work it all out for yourself. And for you guys, I have some news. This will be really, really handy for any of you that want to get into those black epoxy modules. Now, people think you can't. I've had a guy who tried to get into his own. He tried to use a damn surface grinder on it. No, don't do that. It cut all the tops off the surface mount components. But I've possibly got a way to do it. And the trouble is, if I say how to do it, it wouldn't surprise me if they change their formula in later detectors so you can't do it. So I don't even know if I should put it out there. But I've got some. I'm waiting for one to turn up with a bugged module. I need a bugged module off a 6 or a 7, and I can more than likely strip it down. Now, the one the one that was not saying any names, but the one that was surface ground down, that was partially successful, but the parts had been destroyed. So, dear me. So it can be done. It can be done. It's a little bit of time, a little bit of effort, and it's not really laborious. You just You just have to leave it. So I do have that. Really, I'm thinking about actually letting that out of the bag, because it could, whoever they're getting it off, that resin, they might reformulate it to be resistant to this way of doing it. I don't know. Maybe I should do it. If you bring me your modules, I'll strip them down for you. Then you can do whatever you want to do with them. But yeah, let me think on that. I'm gonna consult with Dave on this, because I think he's going to say, no, don't tell anybody. I'm pretty generous with a lot of information, because a lot of it's hard to come by. A lot of trial and error on stuff, I tell you. But that was a lot of trial and error, and yeah, if I can get one apart, it'd be really good. Making sure that's still on. It flipped over for some reason. The microphone flipped over. So yeah. Okay. Well, first of all, what I'll do this, and I will suss this out for its ground balance wanderings, and just see if it is that, or it could be one of the ICs with a temperature issue, or some issue. And if you want to find out what that is, you need someone on the coil bouncing a hot rock on it. And what you do then is you heat the chips with freeze spray, right? And anything that moves a million miles away from its set point, replace it. That's how you discover that. It could also be the capacitors around here as well, little capacitors, and on the other side of the board as well, making up filters. If they are ceramic capacitors and they go funny, that will cause the same problem. So anything could cause that problem, the ground balance to drift. Even even if one of the AD797s was playing up, it would cause, in relation, if you're, yes, it could. It can actually do that, or even the 4053, or anything up into the integration stage. There's a heap of stuff that'll cause that. Anything that unbalances the two channels, or changes DC offsets or anything like that, may induce that type of problem. Anyway, I'll find out, but I've still got my suspicions that it was coupling in here, because that's the data line for ground balance. Yeah, anyway, you could probably put little capacitors across here if you wanted to, 0.1s or something, 0.001s from the ground to each connection, or just put 3 capacitors, 1 to 1 to 1 to 1, just to make sure there's any high frequency stuff there. It just shorts out across it. It's not going to affect DC operation, moving a button on and off, but you could put little capacitors there, and yeah, it may stop it picking it up as well. We'll probably stop it picking it up, but I think just slamming it down against the ground plane, or against a ground plane, which is the ground here, may stop it. The other thing too to check on these, and I gotta reiterate this. Okay. I'm glad this is a 4500, by the way. Hang on a second. That's gigantic. Okay. Let me think about this for a second. Okay. It hits you like a brick. I've been down this path before. Remember years ago when I was doing these detectors, and I found that the plate, the alloy plate here and on the back, which is obviously that alloy plate there, was not connected. This is very early on. Was not connected to ground, as in the circuit board. On these, battery negative is connected here. You can see there, they got that little eyelet there that goes onto battery negative, goes in the circuit board. So we have a ground from there, and on the back part, they've got on there and they give that a little bit of a kiss, so it pushes down. It's probably good enough. You can always file it a bit more, guys. If you want, you can file the whole paint off if you want. It does work better, but here it connects. Okay, now it connects through the metal of the whole thing, right? Whoopsie, there's no paint off any of those. So that metal plate on here, the front one, gets sandwiched onto this. There's no continuity between the front plate. This could be the problem, you know. It could be that as well. Maybe it's a combination of the two, because you've got paint here. You can't get, you know, if I got something and I said, oh, you know, say that was metal, and I'm trying to short it out. It's on paint. It's insulated. There's nothing it can go to. And then people will say, but the screws go into the metal. Now, I've been down this path before, and I'll explain it again because it's in one of my old videos and no one will ever know. So I'll put that down there. But if you have a look, I'll try and do it on here. Okay, let's have a look. Let's look at this the correct way of looking at it. Okay, screws go in here, right? Go in on plastic. Okay, screws come out here. Massive clearance hole. The screws do not touch this alloy. It does not touch it. Then the screws are connected to the metal box. This ain't, or this is not connected. It's floating. This has coil connector on it, a lot of leakage, close proximity. This will all probably charge up. There's no grounding anywhere. The switches aren't grounded. They're all floating. This is all floating. Plastic, 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 plastic. All insulated. So you've got this big plate here that, from a radio man's point of view, would say is live. Partially. It's not grounded. There's no way that is grounded to the box. I can very easily prove it, but I'd have to mount it in the box and then reach in for a long probe and say, oh, look, it's floating. But take my word for it. There's no connection there. Well, how about this? There's a screw. Okay, that's a screw. Probably have to do that, else it won't focus. That's your screw. That's your hole. Put a screw through. Right, I'll prove this to you. I like proving things sometimes. Oopsies. Okay. Butterfingers. Hang on a second. I'll put it there. It'll actually screw into the plastic a little bit, so we'll do that. T10 Torx. In it goes. Now, I don't know if you can actually tell, but here, have a look. That's probably as far as I can go. There. But if you have a look at that screw, it ain't touching. It's got clearance around it. So, and if I go get my, I'll just keep knocking the microphone cockeyed. Hope it's still okay. Yeah. It's going to be a short video, so you get to, damn, we'll get carried away and stuff. But it is interesting, isn't it? It's called How to Fix Your Own Detector. So we use BP multimeter. So if I get these probes, I hope you can hear that. I'll put the microphone on the meter so you'll be able to hear it go beep. There we go. And I'll get this and I'll put it here. And if I push the screw sideways, it'll touch the metal, but not straight. There you go, look, not touching. Now push it hard sideways, I can get it to beep. Continuity, then no continuity. Okay, so it's not even an interference fit. It's a clearance fit there, and there is no way that can connect the metal box to this plate. So yeah, I'm probably not even pointing at it because I've got my head down what I'm doing. Yeah, like I say, this is, if I get it straight, it doesn't do anything. There you go. Go on, and I push it over hard, but the screws don't go in sideways. Right, I can make it beep that way. Now I do it offhand. There we go. There you go. Nothing. See, it's even still bent over a bit. There's nothing there. So it's not really grounded. So, like I say, it sits on the paint. What you need to do, guys, this is the best way to fix it. If you want, I've probably got this. I need a camera operator. Get a file like this, okay, and on where the pressure mounts are, just get the paint off it. Do that in a few places. Makes it hard to see for some reason, but hang on a sec. I'm going to do this properly and I'll show you what I mean. Do it nice and evenly. Don't make a divot. That won't work. You can use the back of a blade. Well, I just use the file. If you can see there, it's all shiny. That'll connect and that'll make a ground connection. Not a problem. But if you want to do it another way, get yourself a blade like so, or even better than this. I'll just do it on the other side. It makes it a better unit. Just get it on there. And that's using the back of the blade, and you can see, just take the paint off it so you can get a connection. But because the screws go in here, 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 and here, that's where you want to take the paint off. Take it off on the screw connection points, because that's where the maximum pressure is to get a good contact. You don't want a dicky contact. But yeah, now that I've done that, I can't prove it to myself, can I? I'll just put some sticky tape on there and isolate it and see if it does it, and then see if it doesn't. So I'll just insulate the sticky tape and try it without, and I guarantee you I'm going to hit the nail on the head, either with that flick down, up, down. I'm going to want it really down. Put this on. Make sure she's connected, and then see if it ground balance drifts. So yeah, oh well, there we go. We went from dongles in 6000s to the older GPX detectors. All good. Okay, catches.